We're live. So, hello everyone. I'm Orkun from CosmWasm and Abel is here. Thanks for joining in. And we are from Confio, the team behind CosmWasm, and we build up this great smart contract framework for you guys. And we are happy to present it to you. And in this call and in this workshop, you will see a contract code from you will see a contract code, and I will show you the how you can interact with it, how you deploy it, how to connect to the testnet, which is made specifically for this workshop. And then after that, Abel will take the microphone, and he will show you how the front end dynamics of a CosmWasm contract works. And yeah, enjoy.
Hey everyone, thanks for joining in. Welcome to CosmWasm and CosmJS dApps 0 to Hero workshop. In this workshop, I will present the smart contract side of a dApp development, and I will not write a contract from scratch, but I will just use the name service contract, which is influenced by Cosmos SDK tutorial to keep things simple. And I will show its components. I will modify the helper STS, which is used to interact with the contract. Then I will compile the contract deterministically, set up WASM CLI, set up the chain ID, etc. Then I will upload it to Heldernet, the testnet network, which is made for this hackathon. And I will instantiate a new contract. Then I will execute the code. Afterwards, you'll be ready and to modify a contract. Then Abel will take the lead and take the microphone and show you the front end side of a contract development. So, yep, let's begin. Let me set this up. All right. So, and you can find the API information here and the RPC endpoints and the REST endpoint. So the first thing we will do, we will clone the CosmWasm example here. So you can clone it using this command right here. It will download the CosmWasm examples repo, which has the name source application inside, but I have already downloaded, so I will just go there. Yep. So, and here is the code itself. Let me close this one. Sorry. Close all. Yep. So, okay. Yep. Sorry. Mhm. So this is the monorepo which contains examples. The example code, you can see ERC20 smart contract and the other smart contracts. These are all smart contracts. So the contract I will be showing you the name service is here, and I have already opened it on IntelliJ. So I will just continue from there. This is the basic structure of a smart contract. This is where the most of the code lives. And the important thing that you should know is cargo file, which is the dependency manager. The cargo is the dependency manager of Rust. And yeah, and then there is the source file, which contains the code, smart contract code. And the first thing I will show you is the messages. And this is the point where you should start as well. This defines the interface of a smart contract. As you can see, we have init message, handle message, and query message. So init message is the message which is used to initialize and instantiate a smart contract from a code. So there could be unlimited numbers of smart contracts that are initiated from a code, and you have to upload the code only once. So we instantiate this smart contract with this data inside here, and these data related to the logic of the smart contract. But yeah, the inside is contract specific, but init message, handle message, and query message is same for all smart contracts. And the handle message is the core logic and the core execution logic of a smart contract. And this is an enumeration. And handle message can be register or transfer. And yeah, so let's see the code to wrap our heads around it. This is the initiation logic. And as you can see, this signature, it comes from the CosmWasm standard repo. And it will be same for all the CosmWasm smart contracts, but it can change between the versions. For example, this message info has been added recently with a 0.11 version. And yeah, it accepts the dependencies. This is for testing purposes, makes testing easier. It contains environment, which has the block information and the contract information, such as contract address and the height of the block, the current height and time of the block. Message info is the Cosmos message. So when you send a WASM message to Cosmos SDK, it is actually a Cosmos message. It keeps the WASM execute message inside, but the rest is the same. So it has a sender, and you can send funds, native tokens, using this. And yeah, and this is init message. So when init message is received, first it creates a purchase. It saves the state to the configuration, and this is a bucket. Let's go to the state now. And yeah, we store the state using this file. Just go and create this, and it will have the functions that are required to modify and access and read the state. I'm not going into too many details because I have limited amount of time. But yeah, you can just think it as the configuration is how you access the config state, and the resolver is the data structure which holds the name service. Yeah, to mention to those who don't know, the name service application is just a very basic domain name system. You set up the contract, and it has the purchase price and transfer price preset up for the names, and you can register domain names. Then you can sell them and you can transfer them, basically. So the handle message, yeah, we have these two functions here. If the register is received, we route it to try register. As you can see, the signature is same, almost same as init message. And what is being done here is the name is validated like this, and we return a contract error if the name is not valid. And then we get the state, we make sure the sent funds are enough to execute the try register. And then if everything's okay, we just save it to the domain name system, to the bucket, and then we move on. And the transfer is almost same. Yeah, basically the same. The query. So we need a structured way to access data, the bucket itself. So this is how you do it with query, and it is kind of identical what is in the Cosmos SDK. So it's same as handle enumeration. You go in and then you route and you query the store, and you do it with buckets again. If there's a data found, return the human address. If not, return none and return it as binary. So we return binary. Yep. So what will I do is pretty basic. I will go just add a new record here, a new data here. Sorry, let me take that. Yep. Let's call it metadata and assign it as string. Okay, sorry, like this. Let's find where it is used. Yep, the name is sent. Let's add it here. Okay, we go here, metadata, and string. Sorry, we don't need one. Yep. I suppose it will compile now, and then you will just find where it is used. And yep, we'll go to register, and then we'll add metadata field here. And the metadata can contain everything. It's just some extra data to define the name. Yep, here we go. Name and yep, I suppose. Is that all? Yes. Now, we have the code ready, but we need to compile it first to be able to upload on chain. So we have some options here. We can use CargoWasm. Am I in the right direction? No. Yes. We can use CargoWasm, which compiles the contract to the WASM binary executable, but you cannot build deterministically. And this is very important, the ability to build deterministically, because let's say if I build my code and upload it to blockchain, but have another party make sure that the contract is actually the thing that I posted there, right? It has not been modified. And yeah, for testing reasons also, it needs to be reproducible and deterministic. For that, we just use the Docker code that we have. Sorry for that. So we prepared a Docker script that will handle this for you, and it is the Rust optimizer. You can go and check the code base. For the repos like this, you can use a Rust optimizer, but for the CosmWasm Plus repo, which contains the production grade smart contract, you should use the workspace optimizer code base. I'm not going into detail, just go and check this repo on GitHub and you'll understand why. And let's run the code. I hope there won't be problems with my computer because I'm using Mac now and recording plus Docker takes huge RAM. And my fan is going burr now. Yep, it's compiling. Yep. We can run the unit tests now, but it is going to cry because I haven't added the metadata field to the unit tests. Instead, I will just run cargo build, and you can build like this also. If you are doing development and you want a fast development cycle, don't use Docker command, just use cargo build and unit test commands. It will be faster. So when you're ready to deploy the smart contract to the blockchain, run it through the Docker. Yep, no errors, cool. So after this, we have our smart contract under artifacts, as you can see here now. So I will start the deployment of it. So, okay. So we will be using the HelderNet for this, which is the network that is just for this hackathon. And you can find the details here. I will walk you through it. And first of all, we need WASM CLI to be able to do this. I have opened the new terminal here. Loading, yep. Go to wasmd, and this code is under git clone. You can get this with .com, CosmWasm and wasmd. clone this one, and make sure you are using the version 0.11, which the Heldernet is running on. And when you first clone it, you'll have this one. Just go check out version 0.11. And yep, to compile, use make install. This command will compile wasm and wasm CLI for you. Yep. Let's see. Version. Yep. Wasm CLI version. Yes, works. So let me take a look at my notes. Okay. So we have the wasm CLI binary ready, but we need to set it up for the Heldernet. And there are 2 or 3 configurations we need to do. And the first one is the config node. So we will point the wasm CLI to RPC endpoint of the Heldernet, and you can find this on here. I'm not sure about the Helder name, by the way. It could be something else. And then we need to configure the chain ID for the CLI. To find this one, just go here. Of course, there are other options, but yep, it's right here. So, and then we will go config chain ID. Yep, it is ready now. And you should set up indentation and JSON. This is optional, but easier. Indent. Okay. Yep, we are ready now. So we need an account to be able to interact. And the way you do it wasm CLI keys add test. And yeah, this is a mnemonic. Don't steal it, please. And yeah, this is my new address. So the key has been generated and our address has been generated, but we don't have any tokens here. And to request tokens, you need to use facet. And the code here is this one. So use just send curry request, basic request to the facet, and let's get this one. Yep, we have some tokens inside. Let's drain it. Cool. All right, so then now let's query the account. Wasm CLI, query account. Wasm CLI. Keys show a test. See, we have tokens inside. Now we are going to store the contract into the blockchain now. Let's close this one. Okay. And the command to that is transaction store is this one. So let me clear it so we can see easier. Yep. So this command it's a transaction command. It stores this wasm code, and these two flags are quite important. It shows where the smart contract is taken from and the builder, and this is for so we use the Docker, right, for Rust Optimizer to produce the code. So you are putting information which version of Rust Optimizer or Workspace Optimizer you use, and people can download the smart contract from the blockchain and compile the code and see if the results match. Yep, go here. I will use the new address now. Okay. Yes, the message is ready, and the long, this gibberish is the WASM binary code representation. And then, yes, shoot. Yep, the code is up out there and it has been stored, and the code ID we have is 2. So we will instantiate the code, but we will use the JavaScript helper TS client to do this. You can use a bash client, a shell client to interact with smart contract, but JSON manipulation is a bit clunky, to be honest, with shell, and helper CSS and CosmJS is very useful. Just please use it. And then, yep, let's go here. So this is the helper CS file that I wrote recently. This it contains the options. It contains the setup details for the client, and it contains the API to our smart contract, and this is just a subsidiary code next to the CosmJS CLI. So in order to use this one, you will run this code now. Okay, so sorry, if here. Okay, let's run it and see what is being shown. Now it's resolving the CosmJS files that is required to run this helper file. Yeah. It's going to run. Anyways. But I need to make modifications. First, this helper file is, this options has been set up for the CoralNet, which is a long-lasting testing network for CosmWasm. But right now we are using a different chain, so we have to set these up. And then I need to make the required modifications to the helper STS, and yeah, because we made some changes to the contract, right? So let's begin by the changes. So I have added a new data here to the register. So let me walk you through. It has the wallet functionalities. It sets up the wallet for you. You can connect. You don't need to know these details in depth if you are just going to use this file, but it's good to know and take a look at it and just look through it. You will understand it. It gets tokens from the facet. Yep, and so the data for the data structures of the smart contract is defined in JavaScript here, in TypeScript here again, and the functionalities are here. You can query the record, you can query the config, you can register, transfer, upload, and instantiate and use. And the functionality is defined here, as you can see. And yeah. Okay, let's see which changes we should make. So we made some changes to the register data string. Okay, let's see the other examples of it if there is. Okay, here, yeah, the interface. I suppose it should work now. And let's edit the example code. We will just copy paste from here. And yeah, let's rename this to Heldernet. I suppose it's done, but we should use this one. Sorry. Okay, got some options. All right, so get it from here, copy. And this was hackathon CosmWasm, but I want to make sure you got it correct. And the network token is, I suppose, no. Okay, it's right here. Let's query. Let's make sure everything's fine. I'm trying to get the token information. I think it's you, Cosm. Yeah. Yep. And the back prefix Cosmos faucet token Cosm. Yeah. If it's not going to work, we'll solve it. And faucet URL. Actually, you don't need to set this up. Sorry. Yeah, you will need to set this up. Sorry. Go here. Default key file. Hackathon. Did I make it correct? Yep. This one. And then any changes here. Yep, it's going to work. Now, actually, with helper.cs, you can upload the smart contract as well, but right now, the code downloads the precompiled code from GitHub release, but we don't have the release. Also, I wanted to show you the CLI and how to upload using CLI. So I just uploaded from CLI, and then I will use the code from here. All right, so let's begin now. I think we're good to go. Usually it doesn't take this long, but I suppose it is because of recording and the RAM usage. So yes, we are ready now. And I will set this up. I will just copy and paste from here and you can use as well. So we will set up a client. Set the password here. So what it will do is it will connect to the network. Oh, it said page 404 not found. So I suppose we made a mistake here. What could be wrong? Ah, sorry, this is the LCD. Okay. RBC. Okay. Reload again. The work I'm doing now and the work Abel will do is quite different. This is a backend and blockchain development side of a CosmWasm smart contract. He'll be more on the front end side, but it's kind of close. Okay, let's see. Copy this one. I hope we haven't done any mistake. Again? Nah. Okay. What is the exact error? Maybe we got the... Okay, yeah. We got the LCD, sorry. Wrong. Yep. Sorry for making you wait. But unexpected stuff happens in life, so please work now. Okay. Come on. Not again. I don't know why. So these are the possible errors that you can get. Okay, okay, okay. Yeah, makes sense. We don't need the node info here. It's going to work now, I assure you. Mhm. Yep. Yes, works. So we set up our client. We actually have a new address. So we generated an address using Wasm CLI, but this is different. So when you use this command here, it will generate a new key and new address for you, and it will go to the facet and request tokens. So you will have a brand new account. But if you create this, it doesn't have to be always like that. So if you create an account using this one, actually it is this key here. This is a default key file. It will go and get the key, and you can provide the key file's location as the second argument here, right here, and it will go and use the key, and it won't generate a new one again. All right, so let's see what is the address of our account. This is the address. All right, so let's see. Let's create the account and see everything is good. Yep, we have some tokens inside. And we can request more tokens, why not? In case if it's not enough or something goes wrong. Yep. And so we will wrap the client with the name service code. Yep. And as I said, we can upload the code using the helper, but we already did it and we will just use the previous code. And then, so I don't know if you remember I showed you the output of wasm transaction store command and the code ID was inside. You can get it from there, or you can query again. Okay, so with Cosmos SDK client and the wasm CLI is exactly the same. You can use the help to get the available info, and we will go query wasm, and we will use list code. Yep, and you can find it with this. As you can see, the builder information and the source information is here, and the creator address is mine. So I will just copy this code here. Oh, wait, I will have to show you the init message first. So init message is the data that will be used to instantiate the contract. So I'll just go here, make the changes here. So the purchase price will be 1000 ucosm, microcosm, and transfer price will be this. Set it up. Okay, and then we will instantiate the code using this, and the code ID is this variable, and here we go. Okay, so what is wrong here? Insufficient funds to pay for fees. New Cosm. Okay. I suppose it was because this is the first time I'm trying it. I want to make it live so I can show you how. Yeah. No, I'll have to. So the problem with this is make sure you set this up correctly, because when you make a change here, you have to reload the code again. I will just do it fast. So I made a mistake here with the gas prices. I fixed it right away. Let's see. Okay, we have token here. I won't repeat these steps. I'll do it fast. No, I have the code here. Okay, nice. Oh, okay. Mm-hmm. Mm-hmm. Yes, this one. Get this one. Normally, you can write the code using you can go into the editor version, and you don't have to put in the commands one by one. You can just edit them in bulk and execute afterwards. Message. Yep. So let's shoot. All right. We have our contract instantiated from the code, and let's get the address. The address of the contract is this one. All right. So if you go into this client again, the helper says launch the command line application, you don't have to instantiate the contract again and again. If you have done it again, you can use the factory use method here, copy and paste your contract's address here, and just continue. And I have a random address here, but this should be Cosmos address. It's not going to work, so we should generate another one. Okay. Yep, now, so this is the execution API interface of this contract and helper. And query the config. Yep. So the configuration from the bucket has been returned to us. And register here, but now we will register data here, a name to our address. Okay. We're waiting now, and the transaction executed. Missing field, metadata. Register. So I added the string here, metadata. Yep, see. So I forgot to put the metadata here, and that's why it's not working here. But I'm not going to restart the client again and make you all go through it. Bear with me. So actually, well, the expected result is same. So when I run this command, I'll be returned a transaction hash. If I can find one right here, it's basic Cosmos transaction hash, and you can query it. And with this code here, the contract record.name, you can query the contract, as you can see exactly right here. Yep, right here, resolve record, and you can query the config, and you can execute the transfer of the name to an address using this one. So yeah, I suppose that's all for now. Let me think if there is any more thing that I can show you. But no. So thank you for watching. The content here will cover the basics of a smart contract, and you can take a look at the CosmWasm documentation. You can take a look at the CosmWasm Plus repo. You can take a look at examples repo, which contains the basic applications. But if you need a production grade repo, please go to the CosmWasm Plus, and it contains our latest version of smart contracts, which is version 0.11, and they will be merged soon while you watch. And thank you for all.
Great. So for the next part of the workshop, we'll be building a dApp from scratch by using our utility packages and the template that we provide. The content, the table of content will be these main points. First, we will take a look at the native wallet that was that is developed here in this monorepo with the rest of the dApps. Remember that you have the instructions for adding a dApp here in the adding a dApp.markdown. We can see in this markdown. Yeah, so please remember that you need to install Node.js version 14 and Yarn version 1.22. At least those are the ones I was using. So the project is test for that for those versions. And remember to use the 0.3.0 release of this repo, of the CosmWasm dApps repo, because right now version 0.3.0 points to the latest commit from the master branch, but master branch is continuously getting new commits and will keep getting new ones the rest of the month. So you will see new changes in the master branch. So please trust the 0.3 release better than the master branch. This also tells you how to use the template, but I will get to that later in the workshop. So first of all, let's have a look at the native wallet. Let's try it out and test it. So I have opened two pages in order to test the back and forth sending of tokens. For one of those, I'm going to use the browser wallet, the burner wallet that gets loaded or created and gets stored in your local storage. And then for the other one, I'm going to use my Ledger Nano S so that we have two addresses and can send back and forth. So this is just the login screen that we will provide to you, and I'll explain its working later. Okay, so now we have two accounts. The browser one has Reef and Shell coins, and the Ledger one only has some shell that that you get it from the faucet. You can see here that there are two different addresses, MU2 and HR9. Okay, so let's send some tokens to the ledger so we can try it out. So let's send some shell. So to this address, we can send, for example, this. Let's click send, and then we arrive to the success screen. This screen we will be explaining later is a reusable component that will be available to you, and you may want to use it. It's a component that lets you show a success or an error message, so it's useful. Then you can go back to the tokens screen. And if we refresh this, you now see that you have a bit more of a shell that you just received from the other address. And to send it back and forth, we can just get this other address and send the shell back to the other account. Because this is a ledger, it asked me for approval, so it will keep loading this spinner. The spinner will keep turning until I approve the transaction. I just approved it, so it should show the success screen. Okay, successfully sent. We see that has 761. We can just reload the app. 1762. So okay, that works. So now I'm going to take a look at the major structure of the monorepo and of the inner projects. So well, first of all, because it's a monorepo, you can tell that by realizing that there's a learner.json file. So this is a whole monorepo, the dApps repo of GitHub at CosmWasm. And so you have the usual config files, the package.json, the scripts, and all of that. For launching a single dApp, you need to first install the dependencies by running yarn or yarn install. I have already done that. It takes a bit of a while. And then for using a dApp, you need to compile the dependencies, these Cosmic dApp dependencies. So you do that by running yarn build depps. This runs this script. What this does is run learner run build, but with the scope of Cosmic dApp logic and Cosmic dApp design, which are these two packages, logic and design. These two packages are dependencies for all the dApps that currently live in this monorepo, which are the CW20 wallet, the name service, the staking service, and the native wallet that we just tested. And we need to run this in order for them to have the dependencies available, since these two packages are not hosted on NPM yet. Right now, well, we'll get to this later when I tell you how to bootstrap a new dApp with the template, which is this folder here. Okay, so yeah, regarding structure, just keep in mind that these two dependencies are TSDX libraries, so they have been created using TSDX, and the other stuff is the dApps are create grabbed app apps. Well, that's it on the structure of the project. So let's take a look at each of the Cosmic dApp utility packages. So let's start with logic, because design, the design package itself has a dependency on logic. So let's start with logic. Logic has, well, it's called Cosmic dApp. That's why I say Cosmic dApp here. And okay, let's see it. So the index just exports everything from config, service, and utils. In config, you have an interface for the configuration of a dApp, or at least the configuration that the rest of the dApps have needed for now. This may grow. So we have an address prefix, a gas price, an HTTP URL, a fee token, a staking token, which is optional, a faucet URL, a faucet token, and code ID and coin map, which are also optional. So coin map will take a look in a moment because it's used here in utils. So in utils we have currency and errors. Let's start with errors, which is really just a function. This function just parses a stack trace from some CosmJS errors. So it does a kind of match and returns the interesting part of the error so you can show a nice message to the user. And then the currency file has several utility functions, like, for example, get a coin and print it in a nice way with the amount and the name of the token, the coin, and printable balance, which formats several coins. You can see that uses the function printable coin in a map and joins it with commas. And then you have the coin map. The coin map is kind of a map of coins with its name and fractional digits. I'll show it right away for the wallet. In the config file of the wallet, we use a coin map. So this coin map is for the CoralNet network. This coin map is used here. And it says, okay, if the native token is ushell, you should show it as shell, and you need to know that there are 6 fractional digits, so you can later format it with the decimal CosmJS utility class. So yeah, that's regarding coin map, and this is used by native coin to display, which turns a native coin into a nice format to show on the UI. And you also have the other way around, the display amount to native. Like if a user enters this kind of quantity in a form, then you can format it in a native way like this and send it to the chain, to the contract, and that will make it properly work. So that would be it for the utils part. And then we have a service part for the logic package, which is mostly context React hooks. So you can see that we have account, contract, CW20, error, SDK, wallet, and protected switch. Protected switch is a component that has no styling. It's just a wrapper around the React router switch. I'll show it to you when we get to the login screen, and there you can see how it's used. And so regarding for example, the error service, it's just a usual global error kind of context. So you have like an optional error. You can set the error message and clear it. That's it. It's not complicated. You got also the SDK, which is really important because the SDK, it's use SDK. No, the use SDK is here. Okay, you will be using SDK and wallet with this hook, but you will also be using some providers, this SDK provider. So the SDK has some kind of utilities for generating a mnemonic, loading or creating a mnemonic from local storage. This is the part where in the login you click on browser here. You go to login. This would be the load or create. And then you have this is used by the load or create wallet, which is an option for logging in with a wallet. And the other option would be loading the ledger wallet, which uses the transport web USB and then a ledger in order to log in. So it would use its wallet. So you can see this kind of utilities there on SDK. You also create the client. So with your config and with a signer, this signer is provided by these load functions, as you can see here, with the offline signer. And here it does some configuration, and then you get the client that lets you get the contracts and all of that. There's also a staking client. The current staking project is a CW20 staking. This would be for the future native staking app, which is not yet implemented. And then the wallet service provides, well, those kind of things needed for initialization mostly. So you kind of have a default context that it's not initialized, doesn't have an address, doesn't have an init function, and all of that. And then you load it and say, okay, so when I get a signer from the load or create wallet, or from the load ledger wallet, you create a client from this signer and this config, and you get the address from this client. If you have a faucet URL, get some, and you don't have any balance, get some tokens there. This could be for the future staking native. And then what you get is, okay, now you are initialized, now you have an address, which would be this. Now the init function will do nothing because you're already initialized. And you also got the client here. Clear is for logout, but it's not, we haven't implemented logout yet. But the important thing is that you can get the client from here and make requests. So yeah, the other thing would be CW20. So for CW20, you got some kind of utilities here, a lot of TypeScript types that make your life easier. So for using this, you will need to use CW20 and initialize it with a contract address. So you could get a code ID with some contracts, get a contract, get its address, and then initialize with that address the CW20 instance. And this would allow you to access all of these queries, the balance, the allowances, token info, investment claims, and some actions like transfer, burn, increase allowance, transfer from. You can play with that. We will see today the wallet, which is a native wallet, so we won't be using this CW20 utility, but you can play with it and you can learn from it. You can learn it from CW20 wallet, our staking service, which is not fully finished, but you can take inspiration from there. So I think that's it for, well, we also got contracts, which is just a contracts provider of CW20 instances. So if you take a look to the CW20 apps, you will see this contract provider that adds contracts from a certain code ID and makes use of them. So that's it for the logic package. And for the design package, we've got two main kind of directories. We got a theme directory, which exposes this global style, and variables. It's used for, we are using the component library, and its app has this config file that uses this override. You don't have to worry about that. So here we export the global style, and this global style uses the other global settings. So you had global reset, which will be this one. It's just CSS, a reset CSS. Global spacing, which uses a modular scale for making harmonic spaced apps. Then the colors, these are all CSS custom properties that you can use. The fonts and the anti-override. This is for overriding specific classes of and D. And the other interesting thing about the design package is the components. We have two directors here, the layout and the logic. The layout are kind of primitive layouts that let you build layouts. So we would have stack and center, which are components taken from the Every Layout book, which is a book that I cannot recommend enough if you want to learn layout. And then a page layout, which has some configuration, like some max width, the space between the elements of the stack component and media queries and all of that. You can check it out and see that they are used all over the apps, and they make my life easier for sure. And then inside the components, we are in the design package, the components subdirectory, and there's another directory called logic, and these are React components that have some logic inside. So there are simple ones like this back button, that is just a back button that uses a history go back, but you can customize it with a path that you want to use. Then we have the loading screen. It's just a loading spinner that you just show while you're doing something. You will see how it's used. And then we have your account. This is your account. Like it's just your address and a button that lets you copy it. It has some options. By default it shows also a title that says your account and your balance, but you can hide it. In this app it's hidden, so it just shows the address. The most important components here in this directory are the login and the operation result components. So the login is, as you may have realized, it's just this view. So we have like a logo and these options. So how it works is these buttons, the browser one and the ledger one. So the browser one calls init browser when you click on it, and the init browser calls init, which is here, but with the load or create wallet, and the init ledger calls with load ledger wallet. This comes from the logic Cosmic dApp. So init sets initializing true, which makes the spinner makes the view turn into the loading spinner. And while that's running, it clears the global error in case the ledger shows some kind of error. It loads the wallet with your address prefix, and it calls SDK init with the signer, which makes your wallet, it loads your address and all of that. And then once your SDK is initialized, you refresh your account to get your address and your balance, and when account is changed, you get pushed to path after login, whatever path you set as the path after login, and if there's a state, it gets pushed to history. Then the operation result will be useful to you when making a transaction. So this is, as you might remember, this screen. This is the successful one. It has a successful message, and go back to whatever screen you want, in this case tokens. So you can see here that if success, it returns the success result, the success icon, and all of that. You will see this better in the wallet when we are using it. Okay, so that would be for the Cosmic dApp, Cosmic dApp utility packages. So let's take a look at the native wallet code, which would be this. So remember that the native wallet code and any of the other apps are create React app projects. So you can see the usual create React app config files like, well, package.json, a readme, a tsconfig because we are using TypeScript. And you can see that there are routes like in any React app that it's making use of React router DOM in this case. So we've got the login, the token detail, the tokens, and the operational result. So we've seen the applications. This would be the login route. This would be the operation result route. This would be the tokens route. And this would be the token detail route. So let's take a look at the proper routes. You may be asking what's the how logging and operation result look since they are used from the design package. So as you can see, it's very simple. We just use logging. I imported as login design in order to use logging for this component. So we imported from the design and we say, okay, for this app, I want that the path after the login is successful is path tokens. I want to name my app wallet so it appears, so that name appears here, wallet. I want to use the CosmWasm logo, which is here in assets. And I want to use the address prefix for, in this case, CoralNet, since this application is used, is configured for CoralNet. So we use address prefix Coral. If you don't set this, it would take Cosmos, and it wouldn't work with CoralNet. The other interesting route is operation result. As you can see, it just uses the operation result design in the same fashion as the login. And you have a default button action that in this case would be go to tokens list, because once we have a successful operation, we want to return to the tokens route. We pass the success icon and the fail icon. Okay, so now for the proper routes of this application. So for tokens, which is this view, we have a title, a search form, a token list, which in this case only has one token. Remember here we have two. And then a your account component that shows our account. So you can see here a title that it comes from and the typography. A form search name, which is implemented here. It's we are using Formic for the forms and YOP for the validation schemas. We're using YOP. It's great. You can do things like this, make it required, match a certain regex with certain length and all of that. Let me get back to tokens. The token list and the your account. Your account, we've already seen it at the Cosmic dApp design package. So here we can take a look at token list, which has a bit more logic. Here we use the use SDK hook to get a reference to the client that we have already initialized. So we use get client for getting the account of the current address. Why do I take a current address as a parameter instead of using the use account hook? This is because in these apps, you can query the tokens of another account. So I can copy this address, go to this other account, copy here, search for it, and I can look at its balance. It can be used, so you can do anything, but you can just query it. So for the current address, I get the account and then set the balance to the balance of that account, and then I show it. Then I do the usual React map for showing several items with the amount and the tokens to display. We use the native coin to display that you might remember from this logic package in the currency utility, and that's the way they are shown on the screen on the token list with the token list component. Okay, so the other route would be token detail. So for token detail, you can see that we have a form. Let me show you the screen. We have a form. Here you set the amount and the address that you want to send to. You can see the balance, the name of the display name of the native token, and your account. So as you can see, we can see the name to display, your account, the amount of the balance, the amount of the token, and the form send tokens form. So so for the form, the same as the other time, we are using dApp and Formic. dApp for validation, Formic for creating the forms, the usual stuff. So for the form, when you submit, we have this action, the send tokens action, which does the following. It sets to loading true, sets loading to true, which makes the loading screen appear with a spinner. And then we get from the form, we get the address and the amount, the recipient address and the amount. The error handling can be improved, as you can see here. I need to add too many decimals requirement in the form validation. We use the utility for display amount to native because we get it from a user input. We need to turn that display amount into a native amount that we can send to the chain. So use get client dot send tokens to the recipient address with the transfer amount. And then if everything is good, if the TX correctly done, we refresh the account to get the new balance of our account, and then we go to we use history push path operation result. So we go to the result screen with a successful message, which is this. This amount of this token was successfully sent to this recipient. We can go back to the tokens screen, and if not, if there's some kind of error, we parse it with the error utility that you saw before, and we send a transaction failed error message and go to the error screen. That would be how you use the operation result component. So now, as you can see here, we use native coin to display because we get the native coin and we need to show the name to display and the balance and the nice non-native format of the balance. So that would be the roots for this application. You can see that there it's very straightforward, but you can take inspiration for them to make in order to make your dApp. So now I'm going to show you how to bootstrap a new dApp from a template, because you don't need to go to packages and make a new create React app project. What you can do with this template folder is explained here, as you may have seen. And so here, what you do is remember to use remember to comply with the prerequisites, and then use the 0.3 release of this monorepo. Then you you have the instructions here, but I'm going to do it to show you how to bootstrap one dApp. Okay, so let's go. We copy the template inside the packages subfolder. We rename it to whatever we want. Let me reuse this name for customizing. I don't know, maybe the README, maybe the package.json, and also the app name in the login screen. Okay, so now that it's copied, we have this new dApp. We need to run. Well, let me stop the wallet application. We need to run yarn again, or yarn install, as you prefer, to get so that this new app gets its dependencies. As you may know, this can take a while, but it will get all your dependencies available. Right. So now we would have to run yarn buildx in order to compile the design and logic packages. But I have already done that. It may take a while, but I have already done it, so I don't need to do it again. Now we go to the new dApp directory and run yarn start in order to start it. This may take a while because I think there is some kind of performance issue between style components, which is what I'm currently using for styling, and TypeScript. I need to fix it, but it's usable. It takes a bit of a while to start the dev server, but then it works correctly and it's perfectly usable. So let's wait for a bit while this starts. Okay, we have this route for a hackathon v-app, and it has finished. It compiled successfully. So we have the same login screen, but tailored to to the name of our app. By logging with the browser, we get sent to the home, but this application is empty and has no home screen yet. So I can make a simple home route so that you can see how it's done. So this is like any React app. You just let's copy this to have something to work. And then we go to assets. It's not needed. Then we go to index. Okay, so just let me remove this. We'll just call it home. This will be our home component for our home route. And well, we could use like this. but we can use the Cosmic dApp design package for using the layout primitives. So we could use like a stack. Let me import it from the design package. That's it. Oh, and also let me import the page layout. Page layout from design package 2. We don't want the whole import path. Okay. And we just put our stack inside. And then I would need some kind of typography here. So let me get it from another project so I can quickly add it. So yeah, this will work. Typography component from the design component library. And we will be needing the title and also the text. So for example, we can do something like this. Home is where the hearth, where the hearth is. And then we could add a text. We can do this, copy text, and say, we can make use of the use account hook in order to get our account. So structure account, use account. This will be imported from the logic service, as you may remember. And we want to use our address and our balance, right? We want to show our balance. However, balance, as you can see here, it's an array of coins. So we need to use well, the printable balance utility that I showcased previously. That is from the logic package. The printable balance that you introduce an array of coins and it joins them together with a comma as a separator as a string. Great. So now we will need to add our home root or our home component as a root of the application. So we go to the app router, which has well, the router is here and is surrounded by all the providers, the error provider, SDK, account. The global style is just adjacent to the router. And then we've got a switch with unprotected roots that both point to login because it's the root path and the path to login. They both point to the login component. And then we have a protected switch that is that you can find it here in the logic service directory. Let me get back to there. And then you can put the roots that you want to protect inside that protected switch, so that if you try to go in one of those roots and you are not and the app is not initialized, you don't have a wallet yet, it will redirect you to the login. That's done by this parameter. There's an auth path, and the path that you put in there will be the path that the user unauthenticated user gets redirected to. Okay, so we got path operation result in there. Let's copy it and add our home component to our home root. Great. So now we should be able to log in and see a title, a balance, and addressing a balance. Okay, home is where the heart is, address, and balance. Great, so now that you have logged in and you have a React component inside the application, you can go crazy with it and build your own dApp. So please don't hesitate to take all these packages, all these dApps as inspiration so that you can build a cool dApp. And that would be it. So now we're open for any questions you may have.
Yep. So if you have more questions, you can ask us on Discord, and you can find the Discord link at docs.cosmwasm.com/chat, and join us and ask your questions there. Don't be shy. We'll be there to help you. Also, sorry, you can go and ask us in Hackathon as well, and please ask there because the content is related there.
We've got some office hours for
Yeah.
giving some mentorship regarding this. So
Yeah,
feel free
we'll be
to
there.